All right, today's lesson is on density. So when you look at something like this, we've got a bag of popcorn and a bag of candy. If I ask you which of these two objects weighs more, I think most of you would immediately say that it's that candy that weighs more. You have some instincts with density, and you've probably talked about density a little bit in the past in a science class or even in a math class. But that's our topic for today is density. You sort of know and you have an instinct and you have had experience in the past that would let you know that that candy is going to be heavier. It's the same size, but it's heavier, and what that means is that candy is more dense. Popcorn has a very low density, and candy has a very high density. So density is the measure of the amount of material per a specific unit of area or volume. First, we're going to focus on density that relates to volume, and then in a minute we'll look at density relating to area. So the first one we're going to focus on is density, the amount of something divided by the total volume. So we're going to start with a wooden cube. A wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. So we know a little bit about this cube. We know how large it is, and we know its mass. We want to determine the density of the cube to the nearest thousandth, and we want to decide what type of wood it is. Different types of wood have different densities, so over here we have a list of types of wood and their probably average density. Oops. Okay, so we've got a cube, and it says each of the edges of that cube is 6. So to calculate the density, we need to know how much, or the mass, and we're going to divide by the volume. So we know the mass already, it's 137.8 grams, and we need to know what the volume of this is. So the volume of this rectangular prism, it's a cube. A cube is a type of rectangular prism, and to find the volume of this, you should know is 6 times 6 times 6, which happens to be 216 cubic centimeters. So now that we know the volume, we can put that into our little equation here, and we can calculate that. So the density of this cube is 137.8 divided by 216, 0.638 grams per cubic centimeter. So this is our calculated density, and if we look at our table over here, you can see that 0.638 looks like it corresponds to ash. So our cube is most likely made out of ash. Okay, in class I had the students work on this, but I'll work through these ones in the video. So we were wandering in a flea market and we found these 3 items all marked as solid gold. So we're going to use the measurements that are given. We have some measurements and we have the mass. And we're going to try to determine which of these objects are likely to be made of gold. Now we know, you can see at the top here, that gold has a density of 19.3 grams per centimeter cubed. So if these objects are made of gold, they're going to have that density. So let's work through each of these shapes. So first we have this little cylinder. Well, it tells us that this cylinder is 3 centimeters wide and 2.1 centimeters long. Well, to find the volume of a cylinder, if you have your reference sheet, it tells you that it's the, let's see, here we go. It's the area of this circle, pi r squared, where r is the radius, and then we multiply that by the height. So the volume is pi r squared times the height. Well, in this case, the radius is only half of the diameter, so the radius is 1.5. And and then we know the height. You know, it's tipped on its side, so sometimes people have a hard time visualizing that 2.1 as a height, but that's exactly what it is. You know, you could tip that cylinder up, and it would be the circle times the height. So the volume here, if we calculate that, calculate it really quick. It is about 14.84 centimeters cubed. So to calculate the density is the mass over the volume. The mass was given to us, 286 grams, and the volume we just calculated, 14.84 centimeters cubed. So the density is 19.3 grams per centimeter cubed, and that matches the density of gold. So I think we would probably conclude that, yes, this is fairly likely actually made out of gold. Let's try the next shape. Next shape is a sphere. It tells us that the sphere is 1 centimeter wide, so I think that means that the radius of the sphere would be half, or 0.5 centimeters. So to find the volume of a sphere, the formula is 4/3 pi times the radius to the third power. So in this case, that's going to be 4/3 pi times 0.5 to the third power. Which is 0.52 centimeters cubed. This is a very, very small little ball, almost like a little bead. Okay, so if we want to calculate the density of this little ball or little sphere of gold, density is the mass over the volume. Mass here is given to us, it's 5 grams, doesn't weigh much, and the volume was 0.52. So for the density, we find that it's 9.55 grams per centimeter cubed. It's much less dense than gold, so I would conclude that this is not made of gold. And one last shape that we're looking at here, this is a rectangular pyramid. If it helps to have those other lines to help you visualize it. It tells us that the base is a 1 centimeter by 1.5 centimeters, and the height is 1.75 centimeters. So to find the volume of a pyramid, it's 1/3 of the area of the base, which would be like length times the width, and then we would times that by the height. So this would be, the LW here is the rectangle at the bottom, and then the height is the 1.75. And 1/3 is for all pyramids and cones. So that would be 1/3 of 1 times 1.5 times 1.75. Which gives us a volume of 0.875 centimeters cubed. It also gives us the mass here. So as we're calculating the density, we know that the density is the mass divided by the volume. In this case, 16.9 grams is the mass and 0.875 is the volume. And so if we calculate the density there, we get 19.3 grams per centimeter cubed, which matches our gold density. So yes, this is probably actually made of gold and not just some metal that looks like gold. So here's a summary for our 3 shapes. The first one, the cylinder, was made of gold. The second one, the sphere, was not. The third pyramid was made of gold. Okay, so let's look at another one that's a little bit more challenging. The density of American white oak is 47 pounds per cubic foot. So we know this density. This is given to us. If the trunk of an American white oak tree has a circumference of 14.7 feet, and if the height is about 26 feet, what is going to be the approximate weight of the trunk? So let's draw this tree trunk. Brown, that's kind of brown. So here's a tree trunk, approximately. A tree trunk is about a cylinder. The problem tells us that the circumference is 14.7. Oh, feet, and it tells us that the height is about 26 feet. So we want to know the approximate weight, the mass of this thing. So we have this formula for density. We know that the density is always equal to the how much or the weight or the mass divided by the volume. Well, in this case, we're trying to figure out, the thing that we want to know is the weight. So we can use the density and the volume to figure that out. So it looks to me like we are definitely going to have to know what the volume of this shape is. Well, a tree trunk is about a cylinder, and to figure out the volume of a cylinder, it's just going to be pi r squared times h, a circle times a height. Well, we have the height is 26, and now we just need to know what the radius of this is. And it didn't give us the radius directly, but it did give us the circumference. So you have to remember that the circumference is 2 pi times the radius. So we know that 14.7 equals 2 pi times the radius. And if we're trying to solve for the radius, we have to divide by 2 pi. You have to be kind of careful when you're putting this into your calculator because the the calculator might not do what you think it is doing. So when you're putting it in your calculator, if you type it in directly like this 14.7 over 2 pi, your calculator actually interprets that as divide by 2 times by pi. It's not grouping the 2 pi together. So as you put it in, it's a good idea to maybe group that, and then your calculator will know that you actually mean to divide by both the 2 and the pi. Okay, so just be aware of that. So when you divide that out, you should just come up with a radius of, let's see, 2.34. Maybe we'll use a couple. 2.34, and that's in feet. So this is a really big tree. It's all like 4.5 feet wide, 26 feet tall just for its trunk. It's huge. So now that we know the radius, 2.34, we can calculate the volume. Pi times 2.34 squared times 26. Which gives us a volume of 447.25 cubic feet. All right, so back to the density now that we've figured out the volume. We know the density, it's given to us in the problem. The density is 47 pounds per cubic foot. And we don't know how many pounds. That's the thing we're trying to figure out. And the volume we just calculated, and the volume was 447.25 cubic feet. Now, you might have noticed that you can kind of use the units to help you decide how to set these up. If you want to use that to help you if you get stuck, it can be a good way to help you. So we have this equation: 47 equals x over 447.25, and I wrote that without units to just try to help you see the math part of it. But if we're solving for x, we want the x by itself, we literally just need to times both sides of the equation by 447.25. And when we do that, we come up with 21,020 pounds for the weight of the tree. So this thing is huge. That's an L. This thing is really heavy, really big, enormous. So in this case, we used the density and the volume to help us calculate a weight. And as long as you have two of those three items, you can use those two to help you calculate the third one. All right, so let's switch gears now. Everything we did so far was a density that related to a volume, but density can also relate to area. So here are two pictures of two different cities. Where do you think you could make the most money delivering newspapers if you were the newspaper delivery boy or girl? So you probably instinctually know that that city is probably going to be more profitable for the paper delivery person. And this has to do with a density. This little rural area is much less dense, less people per square mile, and this city would be much more dense, many more people per square mile there. So we can do density as related to area almost the same way. Density is the amount of something divided by the total area. So let's look at some population densities. That's a really common type of density. The 2010 census indicated that Utah has a population of 2,763,885. If the area of Utah is 84,899 square miles, find the population density of Utah. So density is the amount of something. So in this case, the amount of people. And now we're going to divide by area instead of volume. So in this case, the density is 2,763,885 people divided by 84,899 square miles. And when we calculate that, we come up with the number 32.6. And what that means is so people tend to clump together. Population density is like an average. If we average it out, if we spread all of the people around Utah equal distance apart, it means that in each square mile there would be 32 or 33 people. It's okay to have a decimal here because it's an average, so we're not saying that it's a 0.6 person. We're saying that on average there's between 32 and 33 people per square mile. Utah has a lot of empty space, a lot of wilderness areas, so Utah has a very low population density. 32 people per square mile is pretty low as far as populations go. So let's look at another state. How about Missouri? In 2010, Missouri had a population density of 87.3 people per square mile. So this time I'm giving you the density. If the area of the state is 69,704 square miles, we're going to estimate or calculate the population. So same as last time, the density is equal to the number of people or the population divided by the area. Well, the three parts of this that I'm given or I know from the problem is the density and the area. The density is 87.3 people per square mile. I don't know how many people, that's what I'm trying to figure out. And we know the area is 69,704. So we put in the things that we know, and we're going to solve for the thing that we don't know. Well, to get this x by itself, we just need to times both sides of our equation by that denominator, 69,704. And when we multiply that, we come up with a population of, whoops, this, 6,085,159.2. Since this time we are talking about a population, it's probably good to round that to the nearest person. So we would maybe say 6,885,159 people, approximately. So that would be the approximate population of Missouri. Okay, another one. During an experiment, some types of the same type of bacteria is grown in 2 petri dishes. Petri dish A had a diameter of 51 millimeters, and it had approximately 40,000 bacteria after an hour. Petri dish B has a diameter of 75 millimeters and had an approximate population of 72,000 bacteria after 1 hour. Which petri dish had a greater density of bacteria? So we've got to figure out these two densities, and then we can decide which one we think has the greater density. Let's look at Petri dish A. So it looks like we're going to have to figure out the area of these dishes. Well, the area of a circle is pi r squared. So we need to know the radius of this circle, and the diameter is 51. So that means if we divide by 2, we will find that the radius is 25.5 millimeters. So the area is pi times 25.5 squared. Area here is 80.11 square millimeters. For the second petri dish, the diameter is 75 millimeters, so the radius, if we divide that diameter by 2, the radius is 37.5 millimeters. So if we calculate the area of this larger petri dish, pi times 37.5 squared, we find that the area here is, oh, I'm sorry, I made an error on that last one. I hit the squared button, but it didn't square. Sorry. 2,042.8 millimeters squared. Okay, sorry. Second one is pi times 37.5 squared. 4,417.9 millimeters squared. So now to figure out their densities. Well, the density of A is going to be the amount of bacteria divided by the area. And if we divide that, we come up with a density of about 19.6 bacteria per square millimeter. For the density of the second petri dish, the density of B, the total area, let's see, so we want to do the number of bacteria, 72,000, divided by the area of the petri dish. And for this one, the density is 16.3. So the petri dish with the greater density would be petri dish A. It has less bacteria, but they are much denser. They're much more close together. All right, last one. Griffin wants to know how many cats and dogs are kept as pets in his town, but he can't count them all. So he picks 4 blocks at random and counts the number of pets in those blocks. So he's doing something that's called sampling. If the town has 50 blocks, approximately how many cats and dogs are in the entire town? So what we're going to do here is figure out a density, and then we'll be able to estimate for the city. So let's start with the cats, the density of the cats. Well, the density would be how many divided by the area. Well, how many in this case? There's 4 plus 3 is 7 plus 2 more is 9. We have 9 cats per an area of 4 blocks. Well, that gives me a cat density of, if I calculate that, 2.25 cats per block. So now I know the density. I can calculate about how many cats I think there are in the whole city. 2.25 cats per block is X cats per 50 blocks. So to solve for X, you can just multiply those 50 blocks by the density 2.25. So we would maybe say that there are approximately 112 cats. And we could do that same thing for the dogs. Let's see. The dog density would be the number of dogs. Well, in this case, we've got 2 plus 4 plus 5 is 11 dogs per our 4-block sample. Well, that gives us a dog density of 2.75 if we calculate that. Dogs per block. So if we wanted to calculate the number of dogs in 50 blocks, we can do that the same way we did with the cats, and we will find that there are approximately 137 dogs total in his little town. Okay, so that's it for density. So it's always the amount of something divided by either a volume or an area, depending on what your situation is. The volume and area, though, are always the denominator of that little ratio. So the amount of something per total area or volume. That is it for our lesson on density. Thanks.